Hello students, so in this video we are going to solve a question on uniformly continuous. The question is that e raised to the power x square sin x square is uniformly continuous on 0 to 1. Is it true or false? We are going to solve this question. So for this question, let us recall some results. So some results that is very useful for this question. So first one is that that if a function a to b, closed interval a to b to r is continuous, then it is uniformly continuous. And the second one is the product of two continuous functions. Product of two continuous function is also continuous. So with the help of these two results, we are going to show that this one fx equals to e raised to the power x square sin x square is uniformly continuous or not. So here note that let's take gx equals to e raised to the power x square and hx equals to sin x square. Now note that one more result you can add here, the algebra of continuity, that the composition of continuous functions is also continuous. So here note that g of x equals to e raised to the power x is continuous on open interval 0 to 1. Why? Because e raised to the power x square is composition of two functions, that is e raised to the power x and x square. So let me write it in otherwise it will be difficult to understand how it is the composition of two functions. If you take g1x equals to e raised to the power x and g2x equals to x square, then g1 composition g2 equals to e raised to the power x square. So this is continuous on 0 to 1 and this one function g2 is continuous on 0 to 1. So g1 and g2 equal to e raised to the power x square is also continuous on 0 to 1. So this implies that g is continuous on 0 to 1, and the similar way we will take hx equals to sin x square is also continuous on closed interval 0. Note that here it is also continuous on closed interval 0 1. So to prove the continuity of these two functions, it is easy, you can do yourself. It is how it is continuous. Just for hint I am giving that it is composition of two functions. This one is also on closed interval g1 g2. So f is, what is f? That is product of f into g, that is e raised to the power x square sin x square. So it is also continuous on closed interval 0 to 1 by the above properties that we have done here by second one property. So f is uniformly continuous on 0 to 1. Why? Because this one is continuous on closed interval 0 to 1 and this implies f is uniformly continuous on closed interval 0 1. And if a function is uniformly continuous on a bigger domain, then it is also continuous on a smaller domain, means a smaller domain that contained in that domain. So f is uniformly continuous on closed interval 0 to 1, so it is also uniformly continuous on open interval 0 to 1. So here it is now this one is a finite interval. So there is a homework for all of you. You have to check that this function fx, the same function e raised to the power x square sin x square. So that does f is f is uniformly continuous on whole real number. This one is true or false. So this one is the question that you have to check. That we have seen that by 0 1 what we have concluded, this one, that f is actually uniformly continuous on closed interval AB for any AB in R, but it is closed interval. by that means a function is, this one is continuous on any closed interval, so it is uniformly continuous on open intervals, and consequently B implies that for any open interval a to b it is uniformly continuous, where a and b are finite, means a and b are not infinite, means b are not saying this one we have done, so this one we have to check, that is this function f is uniformly continuous for each open interval ab where a and b are finite. Then this implies that f is uniformly continuous on whole R. This one is the question.